Hi, it's Dr. Memori again with another experiment. Central Campus Chemistry 1046 Lab Experiment 3. This is Experiment 3, Chemical Kinetics 2, rate affected by different factors that affect the rate of the reaction. I'm going to share with you the document. We talk about this document. The purpose of the experiment, just like other experiments, is for you to be able to record the data, and when you record the data, you are going to complete your data sheet and submit as an assignment to your professor, me or someone else teaching the class. Now, the factors affecting is going to be concentration, what we are going to study, temperature, catalyst, physical state of the reaction. Sometimes there were like 4 different parts of the experiment. Some parts of the experiment cover more than just like the state. In this, for part A, we have the liquid or aqueous solution for reaction A, and then the reaction B is solid that is reacting with water, and we want to compare the rate when the state is changing. And also for part A2, we are going to increase the temperature and see how fast this reaction is going to take place at the higher temperature. Then we are going to look for concentration, 5 different reactions at different concentration, but the time is going to be different, so we are going to study that. The surface area, we are going to look for 2 different types of zinc and see which one is going to react faster. Temperature effect, a lot of trials, many different temperature setting, and I'm working all by myself, and I'm not complaining because I do it for students, but I hope that you appreciate the fact that I have to do this all by myself. Okay, we are going to study at 4 different temperatures, same concentration of the solution, and see how fast it's going to take place. And then auto catalyst. The catalyst means that one of the products is going to act as a catalyst and is going to affect the rate of the reaction. Or if we do have presence of the catalyst, how it's going to affect the rate of the reaction. Okay, I'm going to close the document and perform the experiment using my lab manual, procedure from the lab manual. So, finding gloves, because we are using silver nitrate. First, we're going to place 2 milliliters of silver nitrate in a test tube and add some sodium thiosulfate to the silver nitrate and look for evidence and for the reaction. So I'm going to show you what's happening here. I'm going to add 2 milliliters. Let me measure it exactly. Makes you feel better. Using a graduate cylinder, I measure 2 milliliters of the silver nitrate and I place in the test tube. Then I have the sodium thiosulfate here. It's 3 crystals of sodium thiosulfate dissolved in deionized water. And I'm going to add few drops, just as add few drops, and let you watch and see what happens, because you need to record your observation. I'm going to add few drops. Okay, a white crystal formed first. Now the color of the crystal is changing. is getting darker color. White crystals form, and the color of the crystal is changing from the white color. It went to like yellow color, and then gradually to black color. Then now we have to record the temperature, the exact time. No, we don't have to record exact time. Now we have the black color. So it took a while for it to, you can replay and see how long it took, because it's just live action. You can say how long it took to get to this color. Now, we are going to test same experiment. Now this time we are going to take the 2 milliliters of silver nitrate, 2 milliliters of silver nitrate, a different test tube. Place the test tube in hot water bath to increase the temperature. Place it in the hot water bath to increase the temperature. Let's see what temperature we have. It's supposed to be like 40-degree temperature. Okay. Now, I want to add the few drops of the same solution, the sodium thiosulfate that I had it for part 1. I'm going to add to this. The part that you are monitoring is how fast the white color would change to black color compared to the other reactions that we did earlier. Let's see which one is going to be faster. Okay. So it changed to black color. Now, if you want, you can replay the video and time it yourself to see how long it took for the first reaction, how long it took for the second reaction. Second one is completely done, and this was at the 40-degree water, or the temperature of the solution was 40 degree. And, compare the effect of temperature also. But you saw the white crystals, it happened like right away. And then it took some time for the black crystals to form. The formation of the black crystals was part B of the reaction. Formation of the white crystals, it was the part A of the reaction. And we did the part B again in hot water. We tested part B in the hot water. Okay, second part of the experiment is concentration of the effect of concentration of the reactant. For that, we are going to take 5 pieces of magnesium. They're all about same height, so pieces of magnesium. Magnesium is reactive metal. It can react with hydrochloric acid at room temperature. So we are going to look at the time that is going to dissolve in HCl if we change the concentration of the HCl. We are going to keep the temperature constant, and in order to keep the temperature constant, we should basically keep these test tubes in a beaker of water, so the temperature doesn't change, because the temperature of the water, we are not doing anything for the temperature of the water to change. So is the water at room temperature? I have to first take it to fume hood, get the HCl in and bring it back here for adding the magnesium. So just for test tube 2, it says add 2 milliliters of water. I'm adding 2 milliliters of water for the test tube 2 and 8 milliliters of the acid. When you read the procedure from the lab manual, it's going to make more sense why I added the 2 milliliters of water to one of the test tubes, because it's trying to lower the concentration. At the same time, it's teaching you how to get the solution by concentration of solution by dilution. So we are going to place 10 milliliters of 1 molar in test tube 1. I have 1 molar adding 10 milliliters. To test tube 1. 8 milliliters of the 1 molar to test tube 2, because I added 2 milliliters of water already. So the total is 10 milliliters. And you can calculate the concentration. To test tube 3, adding 10 milliliters of 0.6 molar. Test tube 4, adding 10 milliliters of 0.4. And to test tube 5, I'm adding 10 milliliters of 0.2. 0.2. To test tube 5. I have them labeled as like 0.2, 0.4, 0.6, and 1 molar, so I don't get confused later. Okay. We have the acids are already added to the test tubes. So you can see we have the acids already added. We keep it in the water to make sure that we have them all same temperature, so the temperature doesn't change. And I have 5 pieces of magnesium. With the 5 pieces of magnesium, I'm going to find out how long it takes for each one to dissolve completely. Okay, so I'm going to start with the one with the lowest concentration, I guess, or the highest concentration. If I do one at the time, I'm going to try one at the time, because with the 1 molar, this is the 1 molar, so I have the 1 molar. I don't want to have to start all over again, so I'm going to add the magnesium to the 1 molar solution and start timing. I'm waiting to see how long it takes for it to dissolve completely. It has to dissolve completely. Adding, I just found another timer, so to my test tube 2, I'm adding 1 more. It forms bubbles. This is a slower reaction. This one forms bubbles, but has not dissolved yet. Okay, so So I'm going to place in water and wait for it to dissolve. And it tells you how long it took for 1 and the test tube 2, which is a 0.8, but you have to do the calculation to find what is the concentration. If I find another timer, I can start at 0.6. Wow, they were generous. They gave me more timers. So to 0.6, I'm adding a piece of magnesium starting. So now, before I get confused, I don't like to, I like to keep track. So I'm going to label my timers. This one is for the 1 molar, 0.8 molar. So I know which one is which. 0.6 molar. So I have my timers also labeled. And it says the deal is that they should completely dissolve. If I can handle more than 3 timers, I can get another one and add another timer, because some of these reactions are going to be very long. 0.4 timer. Adding a piece to 0.4 and start the time. Nothing has dissolved yet. I'm expecting the 1 molar to be the fastest and dissolve first, but it has not dissolved completely yet. Almost there though. Okay, first one dissolved completely at 256 seconds. So for the first one, it took 256. So this is for part B. It took 256 seconds for mg. Okay, let me choose. I don't want to miss it. 0.8 coming next. Okay. 0.8 dissolved. 0.8, 348. Okay, to check, and it's going to take longer for 0.6. So, but my timer for 0.6 is right here. Still, I have the piece of magnesium in there. I just want to make sure you see it. See that still floating in there? That's for the 0.6. It's been 358 seconds already and is expected. It's going to take longer than the 0.8. So just going to leave it in water for the temperature control to make sure that the temperature is controlled. And I keep just stirring, mixing, and continuing. If I didn't have the timer, it would be much longer. I mean, it would have taken much longer. But at least with the timer, now I'm done with 2. I already gave you the number, 348 for the 0.8 and the 256 for the 1.0 molar. Done with 2. Hoping that 0.8, 0.6, sorry, to be done soon. But they're taking their sweet time. I'm going to move. Most likely, I will move to the next part of the experiment, knowing myself. Okay. For part C of the experiment, we are going to check the surface area while I'm waiting for these reactions to happen. Because it's taking time, I will be monitoring. I will be monitoring the time, but it's a slow reaction. I can do some work ahead of time for the other experiment. So I need 0.5 grams of measure, so I'm getting ready for the next part of the experiment. About 0.5. 0.6, almost there, but still a piece of magnesium still there. So just going to give some time for 0.6. And while doing that, I can measure my granular zinc. I measure the zinc shot. Measure the granular zinc. Almost there. For 0.6 to dissolve. The 0.6 is the concentration of the HCl. The time to dissolve Mg, the magnesium, in the 0.6 concentration. And here's my timer. I'm going to start 680. Okay. I need 5 ml of 6 molar HCl in 2 test tubes. I'm going to bring it, have it ready. I'm not putting any data in until we are done with this part. I'm just getting ready for part C of the experiment because this one still is reacting. I don't want to make data so they come in order, but I can use the time while we are waiting. So that's 0.4. Time. 5 milliliters of HCl. I have my chemicals ready for the part C of the experiment, waiting for reaction to finish for part B first. Well, by the time the 0.2 molar HCl is going to dissolve the magnesium, I think it's time for like a lunch break, or because it's taking a really long time. So we're done with the 0.6. 7.8. I'm going to take these. Point 4, we still have the magnesium in there. So okay. Point 4, I have 878. Completely dissolved. I'm going to place it here. Okay. Okay. We have the point 2 left. Is at 900. A long way to go. We have a big piece of magnesium still there to dissolve. So I might leave it alone. Go get the, can start the part C of the experiment, because part C of the experiment is not asking us to record the time. It's just saying to observe the reaction for the two. Okay. So I'm going to leave this point 2 go on, and I'm going to start the experiment for part C, because I don't have to put any numbers. It's not going to take the numbers out of the line. So just going to show you the difference. The zinc shots, pieces of zinc, larger pieces of zinc. So we are going to compare the reaction for this. The larger the piece is, the smaller the surface area is going to be. And then we have the granular zinc, which is smaller grain size of the zinc. I'm going to label one just with the circle. That shows for the shot, and then the other one, it shows the grains. So for recording purpose is going to help us. So I'm adding the zinc shot into the one that is labeled D. The bubbles are forming. Okay. And I'm supposed to send the other one also at the same time. So I could hold both of them for you, even though it's not the safest, but because of the hydrogen gas that is being released. Okay. So compare the rate. And here is the indication. You see the granule and then the shot. The more bubbles forming or faster formation of the bubbles is a faster reaction. So it's more of a qualitative analysis. We still have zinc in both of them, but the reaction for the granule is much faster. That's all it's asking for now. Doesn't say to time it. It doesn't say to wait until completely done, but just compare the two, the granular versus the zinc shot. Faster formation of bubbles, faster reaction. Okay, point 2 is taking sweet time. It has been 1100 seconds and still reacting. I cannot stop the reaction. I'm just going to wait until it's done. But while it's done, I can prepare for my next step, which is 3 milliliters of potassium permanganate. 3 milliliters of potassium permanganate in 4 test tubes. One part. I need oxalic acid in a different test tube, so I have my test tubes 2. The 0.2 HCl still working, and we have 1200 seconds already, 1265 seconds already. Okay, I think I have time to get the potassium permanganate at least. So I'm going to get the potassium permanganate added to the 4 test tubes. don't want to be absent too long. Still is going on. Still have that. Okay. How long? 1400 seconds. That's still going on. For potassium permanganate, it's supposed to be like purple color. Don't see any purple color. Maybe it's just very low concentration. I hope it works. Hope I don't have to repeat the experiment, but 10 milliliter of oxalic acid in other test tubes. So test tube 2 is going to be 10 milliliters of oxalic acid. This is the permanganate they gave me. It's 0.001, but there is no shade of purple, so it's going to be discovered. See what I'm supposed to. This is just a test for me. It's not for you. Just a test for me to see what is that I expect to see. Because if it doesn't show any color,
Where is it?
potassium permanganate, you left it in fume.
Oh, it's that one. That's the only one. I think. I gotta tell him.
Okay, my test solution for oxalic acid and permanganate showed no evidence for any reaction. I assume that the permanganate has been left for long outside, so I have to make a fresh solution of permanganate and continue the other part of the experiment. Part D of the experiment. It's a long experiment on its own. I didn't expect this to be the problem, but if I don't have any color, I cannot record color change. So it has to show color change to me. It shouldn't take too long if I get the permanganate in my hand fast. I can probably do it quickly, but I have to get the permanganate first. At least we have something to work with, right? Our point 2 is still reacting. And part 4 of the experiment says just use those samples from part E of the experiment. It says that to use the sample from part D. No need to repeat this here. Just record the temperature and time from part D. So we only have one part left. So it's the part D that we have to work with. What's supposed to happen here is we are supposed to have a purple color, and with the purple color of permanganate, it should disappear when we are adding oxalic acid. So in this case, because the permanganate that we have has no color, we cannot record a time for color to disappear. So I have to make a fresh solution, but my fresh solution might be too pink. I think I can fix this quickly. I'm trying to fix it quickly. And let's see how many drops I should add. So I'm basically designing a new experiment for you here. Let's see how long it takes for this to disappear. This is just a test. It has nothing to do with your test tubes yet. Okay, I didn't forget about the 0.2. Still is working. I have to get this experiment fixed. Okay, I'm trying to get the solution to this color, pink color. Then add oxalic acid. Wait for the color change, for the color to disappear. Want to see how long it takes for the color to disappear.